Here's a series circuit, and if you follow the charges, follow a charge round the circuit, then you can see that during its journey from one side of the battery to the other, it loses all of its energy. Look, all of these charges have zero energy. Some of these charges don't end up with like a little bit of energy coming out of the other bulb. Remember that the charges don't begin at the battery. They're already there everywhere in the circuit because they represent electrons essentially, or clumps of electrons, and they all start moving very slowly everywhere at the same time. But if we follow one of these charges from the battery and we waited a long time for it to make its way all the way around the circuit, then it would lose all of its energy. And it doesn't matter what the voltage is, and it doesn't matter what happens with the bulbs. They always lose all of their energy. So the PD across the battery is 6 volts, and we can check that with our voltmeter. 6 volts, like that. So if the PD across the voltmeter is 6 volts, then I wonder what the PD is across each of the bulbs. Well, it seems to be that you've got 6 volts here, and it looks like about 3 volts here and 0 volts here. So 6 to 3, that's a difference of 3 volts, and then 3 to 0, that's a difference of 3 volts too. So it looks like the PD across each bulb should be 3 volts. It's 3 volts across that bulb, and it's also 3 volts across that bulb. So that's a useful sort of a rule, that the PD across the battery, which is 6 volts, is equal to the sum, the addition of the PD across every component that's in a particular loop. We'll call this a loop. If we change the resistance of the bulb, so say for example we change the resistance of this bulb here so that this was 4 volts, well, the PD across the battery is still 6, we haven't changed that, and you can see that the amount of red stuff hasn't changed. So I wonder what the PD across this one will be. Well, if it's 4 here, you'd expect it to be 6 minus 4, which is 2, so let's just see whether that's the case. 6 minus 4 is 2, and if I just change it to some sort of random amount like this, if this is 3.5, then you'd expect this, the PD across this bulb, to be 6 minus 3.5, which is 2.5. Now you might find it's not exactly 2.5 because you just get a little bit of a rounding error sometimes. Let's just see, there we go, 2.4, so that's near enough 2.5. So that is that's the useful notion that what's called the sum of the PDs, the summing together of the PDs, is equal to the PD across the battery.